So I wanted to talk to you a little bit, continuing with the action potential video. I wanted to talk to you about synapses and neurotransmitters. So just to review, the action potential is the nerve impulse traveling down the axon of the neuron. It's like the electricity. If you imagine that the axon is an electrical cord, the action potential would be the electricity traveling down the electrical cord when you turn something on. So if you look at an extension cord, so on an extension cord we have this end and here's the little plugs and they go into the wall outlet, right? So here's the wall outlet, here's the little holes. So let's plug that in. We're going to have that extension cord, and then here's the extension cord traveling across your floor, and then at the end of the extension cord is another end. It kind of bulbs out there, right? And it has the two little holes for prongs in case you want to hook up another extension cord to it and make it longer. So now we have another extension cord, and here's the prongs, and so if you've ever, I know we've all taken two extension cords and plugged them together, like to make Christmas lights or something, in order to make the extension cord longer. So if you imagine the two extension cords you're plugging into each other, one end has the little holes in it and the other end has the prongs, and they plug into each other, and the electricity, let's see, the electricity can go down both extension cords and get to where it needs to go. Now, if you think about it, where these two extension cords meet, the junction where these two extension cords would be plugged in is called the synapse. So the synapse is the junction where two neurons connect. And it doesn't have to be two neurons. It could also be, it could be a neuron to a neuron, or it could be a neuron to a muscle, and so on. It doesn't have to, it can be something else. It can be a neuron connected to like a muscle or something, but I'm just going to concentrate and use as an example a neuron to neuron connection in this video. But it's pretty much the same thing, even if it's neuron to muscle. So how does the nerve impulse jump from one neuron to the next? Well, there are two ways, depending on the type of connection and depending on the type of synapse. There is a chemical synapse, and there is an electrical synapse. Now the chemical synapse, this is the type of synapse that is the neuron to neuron connection. Neuron to neuron. It is the most abundant, and it's also neuron to muscles usually. It's the most abundant type of connection. And in a chemical synapse, the synapse itself has a gap to it. So here's the end of one neuron, and here's the beginning of another neuron. And see, there's a little space right here, and it jumps from the end of one neuron to the beginning of the next neuron. It jumps across the gap. Now, an electrical synapse is less common, and it connects by touch. So there's no gap between an electrical synapse. They're butted right up next to each other. So the electricity can jump across, or not really jump across, but climb across, kind of like a ladder. And this is much less common. This is more common in like your brain, the neurons in your brain. The chemical synapse is all over your body, neuron to neuron transmission, and also neuron to muscle. And in this video, I'm going to be concentrating on the chemical synapse as an example, because I'm using the example of a neuron to neuron transmission. So that's going to be a chemical synapse. And this is the biggie. This is the one you really want to make sure you understand, because this is the most abundant anyway. Now, in a chemical synapse, say we have two neurons. So this is a chemical synapse. We have two neurons. Here's the end of one neuron, and here's the beginning of another neuron. So this would be neuron number 1 and neuron number 2. So neuron number 1 would be considered the presynaptic neuron. And here is the synapse. The synapse is the junction where the two neurons meet. So neuron number 1 would be the presynaptic neuron because it comes before the synapse. Pre means before. And then neuron 2 would, of course, be called the postsynaptic neuron. Post meaning after. So after the synapse is the postsynaptic neuron. Now also something you should understand is that in the chemical synapse, since there's this space, there's this gap between the end of the presynaptic neuron and the beginning of the postsynaptic neuron, this gap is called the synaptic cleft. Cleft. And a cleft just means a gap. So to understand how the impulse travels across the synapse and goes from neuron to neuron, first we need to understand a little bit about the anatomy of the neuron. So I'm just going to draw out a little neuron here. Here's a dendrite, here's a dendrite, here's a dendrite, here's a dendrite, 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 all over the cell body. Oh, that looks terrible. Here's the axon, and then at the end of the nerve, it fans out into this little bulb called the end bulb. So these are dendrites, all of these, and they're sticking out of the soma, or the cell body, and that's like the head of the neuron. This round part is the soma, the cell body, and the dendrites are sticking out of it. And then here's the axon, and that's where the action potential travels down the axon. And then down here at the bottom where this fans out, this is called the end bulb. That's the end bulb, this whole thing. The end bulb of the neuron. And then when a neuron connects, like here's the end bulb of one neuron, and it goes right up to, it butts right up to the beginning of another neuron. What part of the neuron is this beginning of the postsynaptic neuron? This would be a dendrite of the neuron. That's where the end bulb connects up to. It hooks up to the dendrite of another neuron. So here's another dendrite, here's another dendrite, here's another dendrite, 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 dendrite. And here's in the second neuron, here's the soma, the cell body. Here's the axon. And here's the end bulb of the second neuron. So as you can see over here, this is neuron 1. That's presynaptic. And this is neuron 2, the postsynaptic. And as you can see up here, this end bulb ends off right before the dendrite of another neuron begins. And then there's a gap there, the synaptic cleft. So keep that image in the back of your mind as we discuss the synapses, the neuron transmission across the synapse, so you can see the context in which this is happening. Now let's look at the end bulb of the first neuron, a close-up of that end bulb. So remember, here's the soma, dendrites, axon, end bulb. So we're going to be looking at the end bulb. Here's a big picture of the end bulb. So here's the end bulb, and bulb, and the axon is up here, and it goes all the way down until you get down to about here. And remember, this is wrapped all the way around this cylindrical axon. So this is actually just one sheet of red of the plasma membrane with the action potential in it. So, but the where it ends, where this where the axon ends down here at the end bulb is called an axon terminal. And that's the space where the action potential ends, traveling down the axon. Remember, we got the action potential, that's the electricity. Here's my crappy lightning bolt. Travels down, 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 until it gets down to the end terminals. Alright, so now we got the action potential down at the end terminals. What happens when it gets down to the end terminals? Well, part of the anatomy of all this is right outside the end bulb in the extracellular space out here. Here's the extracellular. Are calcium ions. Here's some calcium. Here's some calcium. And the calcium just hangs out down here around the end bulb. And at the end terminals, remember how the voltage-gated channels let in the sodium and everything on the plasma membrane at the axon hillock? Then right around the end terminals at the end bulb, there are gated channels. There are more voltage-gated channels. And remember, the voltage-gated channels flip on when it reaches the action potential, and the voltage-gated channels are what let the sodium in to depolarize the plasma membrane, the membrane potential. Well, these are also voltage-gated channels, and they're triggered by the action potential coming down here, and the electricity of the action potential buzzes these, and you buzz the door and the doors open. But instead of letting sodium ions in, these are specifically for the calcium ions that are hanging out down here. These let the calcium ions in. So these are voltage gated calcium channels. And when the action potential comes down here, it hits these voltage gated calcium channels, the electricity buzzes it, the channels open, and the calcium floods into the end bulb. The calcium goes into the end bulb. And so the calcium, that's how the calcium gets inside the end bulb. Now inside the end bulb are these little doodads, these little circles. I'll put SV. And these are called synaptic vesicles, like popsicle, vesicle. Synaptic vesicles. And that's all of these. There's all these floating around in the end bulb down here. And when the calcium comes in, that's where the calcium goes. They go to stimulate these these synaptic vesicles. Let's review, just really quick, review the anatomy. So we have this axon coming down and it turns into an end bulb. The plasma membrane that was carrying the action potential, it comes down all the way to the end bulb, and then it kind of stops at just before the very tip of the end bulb. And these are called end terminals. And this is called the end bulb. Now, at these end terminals are voltage-gated calcium channels. And right outside, floating around in the extracellular space, is calcium, or calcium ions. And the calcium ions use these voltage-gated calcium channels like doors to get inside the end bulb. So when the action potential comes down and stimulates those doors to open, the calcium floods in. Inside, the calcium goes to synaptic vesicles that are they're just little like bubbles. A vesicle is like a little bubble. They're little bubbles inside the end bulb. Now that we've established that, let's take an even closer look into this end bulb at these synaptic vesicles. Here's some synaptic vesicles. Inside the synaptic vesicles are acetylcholine, and that's abbreviated ACH. I'll write it down here for you. Acetylcholine. Now, acetylcholine is a neurotransmitter. And a neurotransmitter just means something that transmits between two neurons. So that's why it's called a neurotransmitter. It transmits between two neurons. So when the calcium ions come in through the doors, through the voltage-gated calcium channels, they come in and go to these synaptic vesicles, and it stimulates this ACH, the acetylcholine, to get released out of the synaptic vesicles. It bursts these synaptic vesicles apart, kind of like cracking an egg. So you crack the egg, you crack the synaptic vesicles open, and the ACH all floods out. Acetylcholine. The acetylcholine all floods out. And where does the acetylcholine go? It goes out into the synaptic cleft, that gap between the two neurons. Into synaptic cleft. The gap. And see, here would be another neuron waiting to receive, waiting to get stimulated by the second neuron. Here's neuron number 2. So here's the gap, the synaptic cleft, and the acetylcholine comes out into the synaptic cleft. So now we have acetylcholine out here. So now we have the ACH, the acetylcholine, is out in the synaptic cleft, in the gap between the two neurons. And what does the acetylcholine do? Well, just like there were calcium doors, voltage-gated calcium channels up here for the calcium to rush in, down here on neuron number 2, there are chemical-gated channels. Now, these are not voltage-gated channels that are triggered by the electricity buzzing it. These are chemical-gated channels. And the reason why they're chemically gated is because they open when they're stimulated by a certain chemical instead of being stimulated by voltage of electricity. So here's some chemical-gated channels. And the acetylcholine comes down, and the acetylcholine, the transmitter, the neurotransmitter, is the chemical that stimulates this to open. So the chemical comes down, stimulates these to open. The acetylcholine comes down, stimulates these to open. Now, what are they opening for? They're opening for sodium. And there's sodium hanging out around in the extracellular space up here, just like it does around the axon. It also hangs around at the dendrites at the beginning of the neuron. There's sodium, 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 sodium hanging out all around down here. So when the acetylcholine stimulates these doors, these chemical-gated channels to open, the sodium can get in, and the sodium flows in. Now, what happens when sodium flows into the cell? It creates a graded potential, because when sodium floods into the cell, what does it do? It's positive, so it raises the millivolts of the charge of that membrane. Just like we went over in the first video, Um, when the sodium comes in, the positive charge, it makes it more positive inside. So since it's more positive inside, it makes the membrane, the plasma membrane, um, increase in millivolts until it goes from 70 to, or negative 70 to negative 60 millivolts. And this voltage, these positive voltages, travel down the neuron until it gets to the axon again, where the action potential starts all over again. So really that's it. If you want to go back and review the first video that describes the action potential and it goes over the gated channels, and then you can go over this one again and it will all be put into context. So this is sort of a cyclical thing. This causes the action potential that I went over in the first video, but the action potential causes the graded potential in the next neuron, if that makes any sense. If you have any questions, please leave a comment or contact me with, whatever questions you have. I'd be happy to help.